Everyone, my name is Aref. Welcome to my channel. And today we're going to solve two harder problems in max power transfer to load theorem. So let's kick off. The first one is this circuit. So we're trying to find the max power transfer to the load. The max power transfer to the load seen from the load. So if I see the circuit from here, let's consider this as my eye, and I'm trying to see my circuit from this perspective. So as you remember, the circuit seen from the load can be simplified into a Thevenin voltage and a Thevenin resistor, and then we have our load. In this circuit, our load is this R at the top right of the circuit. So this part is the representative of everything to the left of the load. So it could be a bunch of resistors and independent and dependent voltage sources and current sources. So we can just represent it as a Thevenin voltage and a Thevenin resistor. What I need to do is the first step is to find the Thevenin equivalent seen from the load, and then secondly find the max power. And as you remember from previous sessions, the max power transferred to the load is V Thevenin square over 4 times R Thevenin. Okay, so the first step is to find the Thevenin voltage and Thevenin resistor in this circuit. How can we find the Thevenin resistor? We know that we should turn off all the independent sources. So in this case, I'm going to turn off this 5 volt here, which is a short circuit, and then I have this dependent voltage source series with this 10K. Over here I have 3K and 2K resistors, and this one is 100 times VO, and this VO is the polarity of this 2K resistor, and this 40K, and over here is the terminal AB from which I'm trying to see the equivalent resistor. So I'm trying to see the equivalent resistor seen from this terminal. If I find this equivalent resistor, that would be my Thevenin resistor. In such scenarios that we have dependent voltage sources and current sources, the best way to solve the problem and find the Thevenin resistor is through a test voltage source, or I just say test source. It could be voltage source or current source, meaning that I will add a test source at the end of the circuit from where I'm trying to see the equivalent. So this is my dependent voltage source, 100 VO. This is 10K. This one is 40K. And over here, I will just apply a source, a test source. Let's consider it 1 amp. And over here, this is the voltage across my 1 amp source. If I find this VO and then I divide it by 1, based off Ohm's law, I know voltage divided by current is nothing but resistor, and that resistor would be my Thevenin resistor. So the finding of Thevenin resistor has turned into finding of this voltage of 1 amp test source. 3K here, 2K, and that's the voltage across my 2K. So let's try to simplify this circuit. So over here, I only have one loop. And is there any relationship between this part and this part of the circuit? I can say no. Whatever is the current coming this way, let's call it I, the same current should come this way. Because this left circuit is not connected to any source. So I can say that this part will be completely omitted from my analysis for finding the Thevenin resistor. So if this part is cancelled out, all remains is this part at the right. Let's just call this V prime of O so that we distinguish it from this VO. And this test current, let's just consider it 1 milliamp instead of 1 amp. So let's just consider this as 1 milliamp. This time only, because the resistors are in kilo ohms, so I need to consider the test current in milliamps. Okay? So, in such case, we will have just two resistors here, and as I cancelled this part of the circuit and I know that there is no current passing to this left side, so the current here is 0. As a result, I can say the VO is 0. Over here, if the VO is 0, so this dependent voltage source becomes a short circuit. It's just a short circuit. So I have 10K in parallel with 40K, and then this 1 milliamp, which is injected to my circuit to find the Thevenin resistor. The Thevenin resistor is 40K in parallel with 10K. That becomes 40 over 5, or 8 kilo ohms. So 8 kilo ohms is my Thevenin resistor. Let's continue to find the Thevenin voltage. In order to find the Thevenin voltage, I would just open my load from these terminals, let's call it A, B, and then I see my circuit from load's perspective, and then I try to find the open source voltage seen from my load's perspective. So I have 5 volts here, I have 3K and 2K, and over here it's VO, and then it goes to the right side, which I have this dependent voltage source 100 VO, and I got 10K here, then I've got 40K here, and over here the circuit is open, and I'm gonna call it V of OC. What I need to find is the open circuit voltage seen from here, from my load's perspective. Okay? So, if we solve the left part of the circuit, that helps me a lot with figuring out and determining this VO, which is used in the right side circuit. How can I figure out this VO? I only have one loop here. Let's call it loop number 1. So if I use KVL at loop 1, I've got 5 volts equals, so let's call it I1, so 3K I1 plus 2K I1. So there's only one unknown, and that is I1, and that becomes 5 divided by 5k, which is 1 milliamp. So I1 is 1 milliamp, and if you follow this I1, it passes through 3k and 2k, and as these two resistors are in series, the same current passes through both of them. So the current of 3k is the same as the current passing through 2k, and that is 1 milliamp. And based on Ohm's law, I know current is voltage divided by resistor. So the voltage is VO, which is unknown, and the resistor is 2k. So kilo and milli cancels out, and VO becomes 2 volts. Okay, that helps a lot, because now I know that this dependent source at the right is 100 times VO, which is 200 volts. So I've got 200 volts here, 10k here, and 40k here. And what I'm trying to find is the open circuit voltage here. So it's all wire, okay, just a piece of wire. So I can say this polarity is the same polarity of this point, and this negative polarity is the same polarity of this bottom part of the circuit. So 200, and this part is open, so no current goes to the right. So again, I only have one loop, so I consider it I2. So the current I2 from Ohm's law will become voltage, which is 200 divided by resistor, which is 50k. So that becomes just 200 divided by 50, which is 4, and 1 over k, which is kilo, becomes milli, 4 milliamp. So the current I2 passes through 10k and 40k equally, and I know that V of OC, my open circuit voltage, is nothing but current times 40k. I hope that you agree with me. The V of OC is my current, which is 4 milliamp times 40k. So again, kilo and milli cancel out, and 4 times 4 becomes 16 volts. 16 volt is my Thevenin voltage. So now let's just go back to check our resistor, Thevenin resistor, which we have here, 8k, and here the Thevenin voltage is 16 volt, and the max power transferred to the load is V Thevenin square over 4 times R Thevenin. So that becomes 16 square over 4 times 8. And that becomes, actually this 8 is 8k. So that becomes 8 milliwatts. I hope that you guys have reached to the same result as I did. Now let's continue on to the second circuit, and again the same question. We're trying to find the max power transferred to the load. So very quickly, the Thevenin resistor. If we want to find the Thevenin resistor in this circuit, the same theory applies, which is the test source. Okay? So what I need to do, I need to just turn off my independent sources while keeping my dependent sources. So over here is Vx, I have 4, and then over here there's another 4, and here is the terminal from which I'm trying to find my equivalent circuit. So that's another 4, 4. This one is V of x, and there used to be an independent source here, which I just turned it off. And from here, I will apply a source, a test source, which is 1 amp current. And what I'm trying to do is to find the voltage across this independent test source. Okay, so what is the best solution for this one? As I have 3 loops here, the first guess that I have in my mind is to try to solve it through KVL rule. So loop 1, so I just called loop 1 I1, and loop 2 I2, and loop 3, which the current passes through this loop, is called I3. And I know this 1 amp is injected from here, so I can say 1 amp current goes to this node over here. Let's just consider it for now and try to solve forming the KVL loops. So for loop 1, so I say KVL at loop 1 over here. So I have I1, which is here, and then I2 is over here. Then what becomes this current is I1 minus I2. I1 minus I2. So the first term of this KVL loop would becomes 4 times I1 minus I2. Continuing, I have this V of x. So I can say plus Vx, or I say I1 plus I2 is over here. And then this I3 is actually the current of this point or this branch, I3. And then I have I1 over here. So the current of this 4 ohm branch becomes I3 minus I1. So I can say I3 minus I1 passes from bottom to top, but if I consider the direction of this loop, when I reach to this point, I'm going down. So that would be the opposite of this one. So I can say plus 4 times I1 minus I3. Or you might as well say minus 4 I3 minus I1, which would be the same concept, equals 0. Now let's go to loop number 2. KVL at I2, or loop number 2. So this I2 passes through this dependent voltage source. Let me just scroll up a little bit. I can just say minus Vx, which is my dependent voltage source, plus 4 times I2, and then I reach here. This is I2, and this one is 1 amp. So 1 amp plus I2 goes this side. I can say I2 plus 1. I2 plus 1. Okay? Plus 4 times I2 plus 1. And then it continues, goes to this 4 ohm resistor. So it would be plus 4 times, and the direction that I'm considering for this loop is the opposite of this direction, which is I1 minus I2. So the opposite direction becomes I2 minus I1 equals 0. So I have 2 equations, but as you can see, there are 1, 2, 3, and 4 unknowns. I need to reduce my unknown variables. I need to have at most 2 variables because I have 2 equations. If we look closer at loop 3 over here, this loop, I3 is nothing but this current source, but not the same, but the opposite direction. So I can say from loop 3 that I3 is -1 because I've considered my KVL loop direction counterclockwise. As you can see here, it's counterclockwise, but I1 is going clockwise. So I3 is -1 amp. That was very fast. So I just reduced one of these unknowns. So I can just substitute I3 with -1. The other thing that I can substitute is this Vx. The Vx from Ohm's law is the voltage across this 4 ohm resistor. So the voltage across a resistor from Ohm's law becomes current times resistor. What is the current here? As you can see, it's I1 minus I3. So this current from bottom to top is I3 minus I1. So I'm watching it from top to bottom. So that becomes I1 minus I3 times resistor, which is 4. And what is I3? I3 is -1. So I can say that's I1 minus -1 becomes +1 times 4. From here, Vx is 4 times I1 plus 4. There you go. Now I can rewrite these equations so that I would have 2 equations and 2 unknowns. So continue on with trying to find this circuit max power transferred to the load. Again, we open the circuit from our load's perspective and we try to see the circuit from our load. And we try to find the equivalent Thevenin resistor and the Thevenin voltage. Okay, let's very quickly start with Thevenin resistor. And again, as we have dependent voltage source here, we have to use a test source. So I'm trying to just redraw the circuit. For Thevenin resistor, I should turn off all the independent sources and just apply a test source at the place of my load and then try to find the voltage across the test source. So I start from the circuit top, over here, and then I used to have an independent voltage source. I just turn it off, and in this branch again I turned off this source, and here I'm gonna apply 1 amp test current source, and I try to find the voltage across this test source, which is my Thevenin voltage. So that's 4, all resistors are 4 ohms. And over here I have Vx, which is the voltage across this parallel 4 ohm at the middle of the circuit. So if we look at here, the heads and the tails of these 2 resistors are connected to the same point. Can I say that these 2 are in parallel? The answer is yes. So let's try to more simplify this circuit. So 4 and 4 are in parallel, and the equivalent will be 4 divided by 2, or 2 ohms. So I can just cut this middle one from here. If I cut that off, what remains, I'm trying to just redraw the circuit. So over here, that's the test source. It goes all the way down, connected to here. So this one is 2 ohms now. This is the equivalent of these 2 4s. and then another 4 ohm, 4 ohm, positive, negative, Vx. So if these two were in parallel, I can say that this Vx will be now transferred to these 2 points, which is here and here. I have Vx because these two are in parallel. So the same voltage applies to both resistors. Now it's much easier. So I have 1 amp which is injected to this point, and let's call this one I1, and the current that goes here, let's call it I2. There is one thing for sure, and that is this 1 amp over here. So if I want to use KVL rule, I'd better not try to apply KVL in this loop, the bottom loop. But if I apply KVL over here in this top loop, and I'm going to just consider it as loop I. So I start from this point, and I'm going to just pass through all these elements and reach to the same point to apply KVL. Let's figure it out. So KVL at loop I. So I start from here, I have minus Vx, and then over here, so I2 is passing through this 4 amp from the opposite side. That would be minus 4 times I2, and then I continue on over here, so I call this current I1. This is the same direction as my KVL direction, so I would call it 4 times I1 with a positive sign, and then I have positive Vx, and then I reach to the same point, equals 0. And I know that I1 plus I2 is 1. I1 plus I2 is 1. And from here, you can see that I1 is passing through this 2 ohm resistor. So I can say the voltage across 2 ohm resistor, which is Vx, based off the Ohm's law, will become 2 times I1. So now let's apply these two into this equation. So instead of Vx, I'm going to write 2I1. So minus 2 times I1 minus 4 times, instead of I2, I'm going to write my 1 minus I1 plus 4 times I1 plus Vx, which is 2 times I1, equals 0. So from here, minus 2I1 and plus 2I1 cancel out. I have minus 4 plus 4I1 plus another 4I1 equals 0. So 8 times I1 equals 4, or I1 equals 0.5, or half. Okay? So if I1 is half, I2, from here, I can just conclude that I2 is also half amps. And then Vx is just 2 times I1. So Vx is 2 times half, which means Vx is 1 volts. So Vx is 1 volt. What I'm trying to find is this voltage over here, if you remember, the VO. How can I figure it out? If I start from the positive point and then I travel all the way through these two elements and then reach to the negative polarity, then I can figure out the voltage across this test source. So I start from here and then I start the trip from the positive polarity and pass all the way through these two elements and reach to the negative polarity to figure out the voltage of VO. So VO, which is nothing but my Thevenin voltage, oh sorry, VO is my Thevenin resistor actually. So that would be my Thevenin resistor. That will become, so let's try to find it now. So I have 4 times I1. I1 is half. 4 times half is 2 plus Vx. Vx is 1. Okay? That becomes 3. Okay, now let's continue to calculate the Thevenin voltage seen from here. So the Thevenin resistor was 3 ohms. For Thevenin voltage, I need to just cut off the load from these two terminals and then try to redraw the circuit. So over here I will have the open circuit voltage goes all the way here. I have 100 volts. It's 4 ohms here, 4 ohms here. That's the Vx. And I've got 20 volts here. And this is another 4 ohms, and that's the Vx again. And another 4 ohms here. Okay. So what I need is to figure out this open circuit voltage, which is seen from my load's perspective. Okay, how can I figure it out? By looking at this circuit, the first thing that comes to my mind is that the current of this branch is 0 because the circuit is open over here, and the same for here. There is no current here, no current here. So I have 2 loops. I would consider writing KVL. So loop 1, and over here I2 for loop 2. So this I1 is actually from here, and then over here I have I2, which means the current of this branch is I1 minus I2. So let's start writing the KVLs for these 2 loops. So KVL at loop 1, which is I1, I have 100 volts over here. That's I1 minus I2 times 4. And then I have plus Vx and plus 20. And then KVL at loop 2, which is this loop over here. I start from this point and travel all the way and get back to the same point. I see minus Vx plus 4 times I2, and this I2 passes over here, so there's no current adds up. So again I have another 4 times I2, and then I reach to this resistor, which the current direction is the opposite of this I1 minus I2. So I can write plus 4 times I2 minus I1. As I said, the direction of my loop is counterclockwise, but this current over here is showing clockwise. Or, sorry, the direction of my loop is also clockwise. You can see here. But when I reach to this point, I go to the opposite direction. It just goes through this 4 amp from the opposite direction. So I have 2 equations, but 3 unknowns. In order to solve this problem, I need to figure out another equation between Vx, I1, and I2. If I look here, and then I follow this I1, and the fact that there is no other current adds up here. So this I1 comes actually from this point. I1 times 4 is our Vx. So Vx is 4 times I1. There you go. So if I just substitute Vx with 4 times I1, then I will have two equations, two unknowns. So I'm just gonna very quickly solve this one. I1 becomes 15 amps and I2 becomes 10 amps. You can just try to solve that and reach to the same values. So I1 is 15 amp, I2 is 10 amps. From here, I know that Vx is 4 times I1. So from here, Vx will be 4 times 15 or 60 volts. Okay, so I have I1, I2, and Vx. Can I figure out my Thevenin voltage here? Yeah, that should be easy. So let's just follow this path here from positive polarity all the way to the negative polarity. I have 4 times I2, and then I have over here 4 times I1, or just Vx plus 20 volts. That is my Thevenin. So 4 times I2 plus Vx plus 20. Thevenin is 4 times I2 plus Vx plus 20. That would be, I2 is 10 amps, 4 times 10 is 40, plus Vx is 60, and another 20. That would be 120 volts. So this is my Thevenin voltage. There you go. Let's very quickly figure out our max power transferred to the load, which is V Thevenin squared over 4 times R Thevenin. And if you remember, R Thevenin we just calculated as 3 ohms. That would be 120 volts square over 4 times 3, which is 12. That would be 120 times 120 over 12, where this becomes 10. So 1200 watts is the max power transfer to the load. Thank you very much for watching this video. Please, if you liked the content that I provided, don't forget to hit the like button at the bottom of this video, and please share it with your friends so that we help everyone grow together. And don't forget to subscribe to my channel so that you will be at the top of all the videos that I provide and immediately notified of the videos once it's published. Thank you very much for your time. Have a good one.